an example problem of motion on an inclined plane. So let's say that our plane has some angle. We have a ramp tilted at an angle of 5 degrees, and our ramp is 30 meters long. And what we're doing is we're on a loading dock here, and we're putting packages, we're setting packages onto the ramp and allowing them to just slide down our frictionless unloading ramp. And what we're wondering is, what is the acceleration of the object down the plane, of our box down plane? How fast is it going at the bottom? When we initially set it up here, v initial equals 0 meters per second. And we don't know how fast our box is going at the bottom. But we can figure these things out. So let's get the acceleration of the box down the plane. In our rotated reference frame, that gravity works straight down, and that we have two components, the AX and the AY. And this question is asking for the AX. So the angle here is theta, and we said that theta equals 5. So AX is just G times the sine of 5. So we can pull out our calculator, and we can solve for this number. So 5 sine times 9.8. And we get that our acceleration is 0.85 down the plane. So AX is 0.85 meters per second squared down the plane. So how fast is this moving? So now we can just pull out any of our kinematics equations for one dimension, and we can solve whichever ones we want. But the one that would be most straightforward is the one that doesn't involve time, because that would be an extra step we have to solve for. So we can use this one because it doesn't have time. So v final squared is 0 squared plus 2 times our acceleration times the distance we move down the plane, 30 meters. And this is actually meters over second squared, sorry. So what we see is v final squared is going to be 51 meters squared per second squared. So when we take the square root, which will be 7.2, so our box gains an appreciable amount of speed going down this very shallow ramp. So our final velocity is 7.2 meters per second. So the idea is when we have inclined planes, we can use our rotated reference frame to get our acceleration down the plane, and then we can use that acceleration in our motion equations from one dimension, solve for things that we need to know.